Alright, we're going to take this problem, x arctan of x dx, and find the integral by using integration by parts formula. And so we've already set up what u is equal to, arctan of x, and dv is x dx, and we took the derivative of u and the integral of the dv and got x squared over 2. So we're just going to put this formula together. We have uv, which is arctan. We have the arctan of x and multiplied by v, which is x squared over 2, minus the integral of v, which is x squared over 2, du, which is 1 over 1 plus x squared. So let me get this out of the way here. 1 over 1 plus x squared dx. Okay. We can't do anything with the first part, so we'll just keep that going in the problem here. And we'll maybe clean this up just a little bit so that the answer might come out a little cleaner. We have 1/2 of x squared arctan of x. And then before we take the integral over here, we can pull out this constant 1/2. So we have 1/2 the integral of x squared all over 1 plus x squared dx. Well, when we look at this integral in the second half of the formula, we notice that we can't take the integral. We can't do an integration by partial fractions because we can't do anything with that 1 plus x squared. But if we could somehow match up the numerators just by this little trick, the denominator has 1 plus x squared. Now the numerator has x squared plus 1, but of course we just can't add this plus 1 without then subtracting a 1, right? So now the quantity in the numerator is just x squared plus 1 minus 1, which is just x squared. So we haven't really changed the problem at all. But if we just sort of put a parenthesis around this, we notice that we have two separate fractions. And let me write that. So let's go back. We still have our 1/2 x squared arctan of x. And then we have negative 1/2 the integral of x squared plus 1 over 1 plus x squared. And then we have minus 1 over 1 plus x squared, and all that is multiplied by dx. So we're taking the integral of this entire thing. So in essence, if you'll just recognize here that when the numerator and the denominator completely match, that just reduces to 1. So if this whole thing goes to 1 right here, that just goes to the number 1. So we're going to split that up into two separate integrals if we can, and we would still have our 1/2 x squared arctan of x, and then we have minus 1/2 the integral of 1 dx, and then we still have our minus 1/2, but if we distribute it to that other minus, we end up with a plus 1/2 integral of 1 over 1 plus x squared dx. And then we can take the integral, because we notice that the second integral over here, this guy right here, is simply arctan. So it'd be 1/2 arctan if we took the integral of that. So let's put it all together. We have 1/2 x squared arctan of x minus, And the integral of a constant, 1, is just x, so we have minus 1/2 x. The constant 1/2 stays out here, and we have arctan of x plus our constant. So just recall that the trick is in this step right here, where we add 1 to our numerator and subtract 1 at the same time so that we can split it up into 2 separate fractions. Okay, I hope this helps.